Okay, so we're going to work on parts of the wave today. So you might want to go ahead and get your paper set up. So let's go over the objective, and then you're going to want to hit the pause button so that you can take and get your paper set up. But we're going to identify the parts of the wave, both transverse and compressional. Okay, and then we're going to calculate and define the frequency of a wave. So you might want to set your paper up as a T-chart. So transverse waves on this side, then compressional waves on this side. Okay, pause it and then come back to me. Okay, you're back. Awesome. So now we're going to take and we're going to start with our, we're going to start on the transverse waves. Okay, so we need to know what one complete wave is. So I want you to draw the wave, and we're going to do one complete wave in this. Okay, so let's label some things on here. Okay, we have the top of a wave is called a crest. The bottom of the wave is called the trough. This line about which the wave pivots is called the rest position. And one of the things that we need to remember when we are dealing with from the lab, just a reminder that the energy goes this way. And then the particle motion goes this way. Okay. And so we know that they are perpendicular to each other. So I'm going to highlight our other vocab words. So we have the crest, the trough, and the rest position. Okay. So let's go over to the compressional longitudinal side now. These waves look a little different when you draw them. So there's two parts to these waves. You have the area where they're compressed, and that's called the compression. And you have the area where they're loose, that is called the rarefaction. Okay, so let's do our particle motion. Keep losing my pen. So energy, notice how energy is the same. Energy goes this direction as it is in the transverse. And then the particle motion is in the same direction. So in this case,
attention staff and students, if you have not already started, this is just a friendly reminder to take the Kansas Community Care Survey. Thank you.
disregard that information. We're going to keep going. Okay, so both of these situations, I'm going to turn my paper and it's going to be weird. This is one complete wave. Okay. So now I'm going to draw another line. And we're going to talk about the wavelength. So notice with one complete wave up here, it has a crest and a trough in one wave. But down here, I'm going to draw two because I need to show you there are 3 different ways to measure wavelength with a transverse wave. So So just as a reminder, top parts are the crest, bottoms are the trough, but then wavelength can be measured 3 different ways. We can measure crest to crest, and I'm going to use the symbol lambda. It can be measured along the rest position from where it crosses the rest to the other rest. Okay. That's a wavelength lambda. And let me move it up a little. And then trough to trough. And that's another lambda. So now we have to define a wavelength. Okay. So the wavelength is the measure from crest to crest, trough to trough, or rest to rest. And then just a reminder which colors are which. Trough to trough is the peachy pink color. Okay. The crest is the blue color. And then the green is the rest to rest. Okay. Now it's a little bit different for the compressional longitudinal waves. In the compressional longitudinal wave, we're going to draw 2 waves just like we did here. So I am going to start out with a compression, and then go rarefaction, then compression, and then rarefaction. Okay. So the 2 waves in this case are going to be the beginning of the compression from the beginning of one compression to the beginning of the other compression, and we're still using the same lambda. Or we can go beginning of rarefaction to the beginning of rarefaction, and then have our other lambda. So it's the measure from rarefaction to rarefaction, or it's from compression to compression. So compression to compression is the green, the peachy pink is the rarefaction to rarefaction. Okay. I'm going to slide up my notes, and then I'm going to turn them sideways. Sorry. And this section is wavelength. And it's measured with our upside down y, which is known as lambda. It's the Greek letter lambda. So then I'm going to draw another line. And now this is only specific to transverse waves. It's the amplitude. So when we have a wave, this is one wave, okay? The amplitude is measured by the letter A. It's defined as the distance to the crest, or not both, okay, or trough. We're not adding them together. It's just the distance to the crest or the trough from the rest. Okay. I'm going to do it again to you. I'm going to turn my paper sideways. I'm going to draw another line, and this will be the next list. The next thing is the last thing. Okay. So now we're going to do frequency. We're going to do frequency. And I'm going to turn it sideways because I want to define it, because it's the same definition for both transverse waves and compressional waves. So let's put frequency over here. And it is measured, and its letter is a fancy F. It's a lowercase f with a tail. And it is the number of waves that pass a given point shorten point with PT in 1 second. Okay? So let's go in and do this now. Okay? So let's do this. So I'm going to draw an example. My waves aren't perfect, okay? And we're going to, for our person is standing here, okay? I'm going to count how many waves. Remember, a wave is a crest and a trough. So this would be 1. This would be 2. Crest, trough. 3. Crest, trough. And then this would be 4. Okay? So in this case, it's going to be F equals the number of waves over T time, okay, which is equal to, there are 4 waves up here, and we would say this is 1 second. So our frequency is, because we're going to put up here, sorry, I didn't put this, T equals 1 second, 4 hertz. Now let me explain that. This is the equation for frequency, okay? And T is always measured in, T is time. We measure that in seconds. Okay. And the units, I'm going to write it bigger, is Hz, which stands for hertz. And Miss Den will get more into that in her video. Okay? So let's look at it from the transverse side. Okay? The transverse side. So let's count our waves. So we know one wave on a compressional longitudinal is a compression and a rarefaction. Okay. Apparently I need to make this look more compressional. Okay. So this is 1. This is a compression. This is a rarefaction. Compression, rarefaction. And then this is 2. And then this is 3. T in this case is still equal to 1 second. So F equals the number of waves over time. We had 3 waves over 1 second, which is equal to 3 hertz. And both of these are the ways we measure frequency. Miss Den's video will deal more about that. The last thing I want to talk to you guys about is I want to talk to you about white space in your notes. Some of you, when you turned in notes on for last week, your notes are very cramped. Your eyes need the white space to recognize things. So notice not everything is cramped together. Okay? Not everything is cramped together. And what do you notice about my notes? What do you notice about in retrospect when you look back at my notes? My notes are colorful. So one of the things, I started the vocabulary like this. I need to finish the vocabulary like this. And some of you do a real good job of going back through your notes and identifying things. So that's all I'm doing right now. hopefully that helps. But hopefully if you have any questions, you know where to find us. Have a great day.